Hi, young ones! This presentation is brought to you by Glennis, Lunel, Tiffany, and Danielle. Today, you will be learning about Chapter 2, Properties of Matter. But before we start, let's get a glass of water first. Ah, refreshing! Hey! Water is a liquid! A liquid is a form of matter but has no shape. But solids are objects that you can hold and maintain their shape. They come in all shapes and sizes. Here are some examples. Even you are a solid because you have a definite shape and volume. Have you ever heard of the word gas before? No, not gasoline, silly. Gas is everywhere. Gas is a form of matter that takes the shape and the volume of its container. Still confused? Well, that's fine. Take this red balloon for example. No matter what shape you shape your balloon, it will still be filled with gas molecules. Gas can fill a container of any shape or size. Even the air you breathe is a mixture of gases, forming the atmosphere of the Earth. These are the three states of matter. Mass. Mass is the measurement of how much matter is in an object. Mass and weight are totally two different things. Weight is the force of gravity on an object. Weight can be changed, but mass can't. The mass will always stay the same. The volume of an object is the amount it takes up. Extensive property. It depends on the amount of matter in a sample, but intensive property, it depends on the type, the identity on a matter. Substance is a matter that has a uniform and definite composition. Physical property. Physical property is a condition of a substance that can be observed or measured without changing the substance into something new. Physical change is a change in the matter that doesn't change what the matter is. Now, for example, imagine you have a glass plate in your hand but accidentally drops it. Oops! Even though it's been broken, it still remains glass. Now let's choose another example. Back to ice. Before ice ever became this state, it was once water, right? But when heat's involved, the ice slowly begins to melt, which in the end will once again be water. Ain't that a physical change? Why, you ask? Because the substance never changed. It stayed water and it'll always be water. Physical change can be classified as reversible and irreversible. You just learned the first section. Section 2. Mixtures. What's a mixture, you say? Well, a mixture is a physical blend of two or more components. Bet you wouldn't guess there were two types. The first one is called homogeneous mixture. A homogeneous mixture is the mixture in which the composition is uniformed throughout. Homo equals same. When it's a homogeneous mixture, the components are hard to indicate. Here's an example. You decide you want to make cupcakes for your friend's birthday. You get all the ingredients that you know is needed. 1 cup of red velvet mix, 2 raw eggs, and water. And don't forget vegetable oil. You begin to add these ingredients together to get your mixture. components are finally mixed together. This is a homogeneous mixture. Because it is hard to point out the different ingredients. Just by looking at it, could you have seen that eggs were added? What about water? Can you tell that water was added? With this mixture, it is hard to point out the different ingredients that were used to make it. Homogeneous mixture. The second mixture is called heterogeneous mixture, a mixture in which the composition is not uniform throughout. Examples: cereal, a pepperoni pizza, and salad. Those right there are examples of heterogeneous mixtures, because you can see the different components in the mixture. Filtration. Are some examples of filtration. Distillation. It is a process where you separate water from other components in tap water. Section 3. Simplest form of matter that has a unique set: elements. Composition: substance that contain two or more elements combined in a fixed proportion: compounds. Compounds can be broken down into simpler substance, but elements. A chemical change is a change that produces matter with a different composition. Did you even know that chemists use chemical symbols to represent elements? They also use chemical formulas to represent compounds. Each element is represented by one or two letters. Element symbol. Here is a picture of the periodic table. Each horizontal row on the periodic table is called a period, and each vertical column on the periodic table is called a group or a family. Section 4. Chemical change. The ability of a substance to undergo a specific chemical change. Iron is able to combine with oxygen to form rust. Chemical properties can be used to identify a substance. During chemical change, the composition of matter always changes. Chemical reaction. Chemical reaction: one or more new substances change into one or more new substances. Reactant. A substance present at the start of the reaction is called a reactant, and a substance produced in the reaction is called a product. 4 ways to tell that chemical has changed. 1. Energy is transferred. 2. The color is changed. Color has changed. 3. The production of gas. And 4. The formation of a precipitate. Every chemical change involves a transfer of energy. A precipitate is a solid that forms and settles out of a liquid mixture. During any chemical change, the mass of the product is always equal to the mass of the reactants. The law of conservation of mass. Any physical change or chemical reaction, mass is conserved, it states. Mass cannot be created nor destroyed. It can easily be observed when it's in a sealed container. And here's an example of that. You've just learned the whole chapter 2. Aren't you excited? Good job. Thanks for watching. And if you want to go back, don't hesitate to. It means you're learning.